Using the power rule to take derivatives needs to become second hand or second nature to us. Almost like 2 plus 7 is equal to 9. We need to immediately be able to apply the power rule to functions. So let's think about this first function here. We've got 6 different power functions. And if we wanted to differentiate x to the fifth, the derivative of this function is given to me by, I move the 5 down in front, and I now have 1 less of a power. So the derivative is 5x to the fourth. In Newton's notation, f prime of x is 5x to the fourth. All right, letter B, g of x is equal to x. So there's kind of like a 1 sitting on that, right? There's a power of 1 that we typically don't write, but there's one x value right there. So g prime of x, by the power rule, the 1 is going to come down in front. And how many x's do I have? 1 minus 1, 0 of them. Now, anything to the 0 is equal to 1, except for 0. Right, x to the 0, if we were to plot that, constantly equal to 1, except just doesn't exist there. So this just gives me a 1. And we kind of already knew that, right? G of x is equal to x, so that's just the identity function, which has a slope of 1, right? The mx plus b, the m there is 1. All right, h of t. So this is a function of t, but I have t raised to some power. So the power rule applies. If we were to differentiate with respect to t, h of t, the 2/5 comes down in front as a multiple. We have our t variable, and now I can't do this in my head, so I'm just going to write this down for now. 2 to the 5th minus 1, right? That's going to be my new power. And now I can do a little bit of algebra and figure out what that is. 2/5 t, I need a common denominator. So 2/5 minus a 5/5. This is 2/5 t raised to the minus 3/5. So if I really wanted to clean this up, I could write this as 2 over 5 t to the 3/5. All right. D, z, which is a function of x. So if we are going to differentiate z with respect to x, that's finding z prime. Before we do that, let's rewrite z as x to the minus 2, right? Just bringing this up to the numerator by having a negative power. That way, I can recognize this as a power rule. If I were to differentiate x to the minus 2, the minus 2 comes down in front, and I now have a minus 3 power, because minus 2 minus a 1 puts you at minus 3. And we can clean this up just a little bit by writing this. All right, the square root of s, written as a power, is equal to s to the 1/2. And if we are to differentiate, we end up at 1/2 s to the minus 1/2, or 1 over 2 square root s. Now f seems a little bit tricky, but we just have to rewrite it before we take the derivative. We have x cubed being multiplied by x to the minus 1/2. I should add their powers, so x to the 3 minus 1/2, which is x to the 6 minus 1 over 2, or x to the 5/2. Now note, we haven't taken a derivative yet. So x cubed over square root of x differentiates to 5/2 x to the 5/2 minus 1. Which algebra can clean this up for us? Cool. So every single one of these problems was an instance of we have a variable raised to a power, and we're differentiating with respect to that variable. the power comes down in front, and your new power is 1 less.